Good afternoon. Thank you. I'm audible, right? Back there? Good? Okay. All right, so before I start, we're going to talk a lot about secrets. But yes, if you want to move forward without me, there is this slide link, or you can scan the QR code and go forward. And the code base that I'm going to use for the demos is there in this second link. And so you can always refer to it offline after the talk. With that, let's get started. So yeah, as Flo was saying, we will look at the problems, different problems of secrets, and what are the different ways by which we try to work around them or deal with them, right? And still, there are limitations to all of them. And so how the hero of my talk, Secrets-CSI driver, can help us, and some demos around all these things. Yeah, I'll be doing demos as I go, so it's not going to be demos at the end, but as I go, I'll try to do the demos. All right. So yeah, everyone knows that we need to use secrets and we need to deal with them because secrets are secrets. We don't want a lot of people to know them. We want to keep them secret, private, only need to know basis. We want to make sure that the access is controlled. But then how do we do it all with GitOps, with making sure that everything is working in automated fashion, right? And that's where the challenges typically are. So the first and absolute basic and absolute crappy as well strategy is to keep it in Git in a normal plain text file, the YAML file, which has your base64 encoded secret, right? So secret is base64 encoded, put it in Git. So now whoever has access to Git, they are going to have access to your secret permanently. So if your production database password is in your Git, the guy leaves your company, you have to get all your passwords changed, rotated after every guy leaves. Yeah, that's not good, right? So we are going to quickly look at a demo of this, just for the covering our basis types. Yeah, and this also gives me an opportunity to help you look at what kind of demos are going to be there, because the same demo structure I'll use for all the 5 demos. So it's a very simple setup that I'm using here for the demo. I have a pod which uses a secret. By the way, the secret is private Git secret. Yeah, and the pod is being connected to a service which is exposed via ingress. Yeah, as simple as that. And so the secret is mounted as an environment variable here. And so if in order for you to show it a little bit visually, there is no need of Argo CD for this particular demo or for all of this learning. Argo CD just makes it a little bit more visual for you. Yeah, so plain secrets app, that is the app that I just showed you. I will sync it, and I will access it subsequently. Yeah. All right. Let me just confirm that it is synced. Yeah. So you can see that it shows whatever is there in the secret. Very, very simple demo, because I don't want to clutter your mind. Yeah. So all other demos will also use the same style, a little bit different maybe. Yeah. So this is what we do for the private Git-based secrets, right? How do I make a slideshow out of it? All right, so as I said earlier, there are problems with it because anybody can read, even after the person has left the organization. If anybody had cloned your Git repository ever, and then you remove his access, can't help, it's still there with him. Yeah, so all these problems exist. Slightly improved option is using what is known as git-crypt. This is a software that comes and works with Git in order to encrypt some bits of your program. So we are going to see that one folder of my repository called secrets is now encrypted. I have told git-crypt to encrypt anything that goes in that folder. So anytime any change happens to the folder's content, like our Git YAML, then it will be encrypted and stored. And that's why if you look at the secrets folder, I hope this is visible to you. Yeah. So you can see that there is a file, but you can't see the file. It says view raw. Yeah. So now, at least if somebody has access to your Git repository, they just can't read the Git secret yet. So it's slightly better. Now your secrets are slightly more securely stored. But of course, somebody has to access it, like your team members, right? So how do you get them access? So you need to give them access by adding them as a git-crypt collaborator, like how you can see that one collaborator, that's me, has been added to repository. And then the other problems with it come along with it. Like if, say, I got him added, now both of them leave the organization, their access is still there. So I have to remove the access, but if they had checked out the code with them, it will still be available to them. And that's what I'm going to show you here quickly. It's a very simple demo, very similar to plain secrets demo. See, if you look at this file, the same file that we were seeing as view raw in the GitHub, on my local, it's not encrypted because I use git-crypt to decrypt it. Yeah, and so you can see the file in plain text. And so here is my secret. But if I change anything here and I push, again the encrypted copy goes in Git. Yeah, so let me now sync this particular application, git-crypt app. Yeah, and you don't have to follow the flow's direction every time. All right, so let's look at this now. And it shows you git-crypted secret. So how does Kubernetes cluster got the content, right? Because the encryption is only at the Git level. When it was on my local machine, it was decrypted, and that's how it got applied. But then how does it work with GitOps tools like Argo CD? Because Argo CD is directly going to Git and getting the Git cloned and deploying. So yeah, it makes actually a lot more difficult to use GitOps tool when you use git-crypt. And in fact, here in my case also, I have used a customized Argo CD for myself. In order for the Argo CD to decrypt the encrypted secret and get it deployed. Yeah, so it is a little bit better, but then you have to make extra efforts to play it nice with GitOps. And if the content is cloned and decrypted anytime on anybody's machine, then it is going to sit there unencrypted fashion. So those problems are not resolved. So some bit better, but not so much. Then I came across sealed secrets. Yeah, sealed secrets actually works very similar to git-crypt, just that it works in a Kubernetes world. So it's more cloud native than git-crypt, I would say. So how does it work? The secrets in Git here are also encrypted. So what you store in the Git is an encrypted version. Yeah, but only the text is encrypted, one-way encrypted. And then in order for it to get decrypted, you need to install something called a sealed secret controller in your cluster, right? So we will see the demo. So it is similar to git-crypt, that just because you have read access to any Git repository, you will not know the secret. Yeah, but and in the cluster, you will actually have the secret available as a plain secret. So the drawbacks, the secret is still readable in the Kubernetes cluster if you have access via RBAC, right? And you also need a specialized CLI available in order to create this encrypted copy of the secret. And that's what we are going to do actually now, the creation of copy. So this is my secret, by the way, that I'm going to use. Yeah, and this is the old copy of the sealed secret that was created by kubectl. I'm going to change it now. So yeah, I mean, just had a make target, but it basically uses kubectl, here you can see, to change the secret. And you can see that the file is now changed. You can see that this old content that was from my old COPS cluster that I used, say 2 hours ago, and this is a new value now. Yeah, so I'm going to push this in. Sorry. Because the secret is very much specific to the current cluster. So you cannot just take the kubectl file from one cluster and push it in other. That is not possible, because at the runtime, the kubectl controller is making an exchange and creating temporary secret and all that. So it has to be with the current cluster only, right? Okay, so I have pushed it, and I'm going to now go to the Argo CD, and I'm going to do a refresh one more time, because I just pushed new code. And once it comes back up, yeah. Okay, so we are now, I will show you this third way of using the secrets, that is sealed secrets. Yeah, and you can see that the file that I had showed you earlier, that's the content that it is now deployed, and yeah, it is showing up on the screen, the same content. Yeah, so that's about sealed secret. Is everything okay then with sealed secret? As I said, it's pretty good solution, I must say. It's pretty good solution, works. But it is still available as a secret in the cluster, and so if you have RBAC to access it, then you are going to see the secret. You can see that this secret that we just spoke about was created 52 seconds ago by the kubectl controller. I forgot to show you that before I deployed, there was no such secret. All right. So is there a way by which I can just skip the Git altogether for storing secrets? We are in cloud native world, and every major cloud provider is already providing us their own ways. And also there is Vault, which is none of the cloud provider, but a dedicated security solution. Right? Can we use any of these tools like HashiCorp Vault, AWS Secret Manager, and all, right? So yes, now thankfully there is a solution available, external secrets operator. What it does is the secrets are now not stored in Git. They are stored rather in one of the cloud provider. And like how it was for the sealed secrets, that we need a controller running in the cluster. Yeah, here also we need to have a external secrets operator running in the cluster, so that that operator has just one work: go and talk to various cloud providers, get the secret, and make it available as secret. So what are the benefits? Secrets are not stored in Git anymore, so anybody can have access to Git, and they will not know the secrets. Secrets are safely stored outside in the cloud providers, and another good part is you can change the secret directly at the cloud provider, and they get synced and rotated in the cluster. That's a pretty decent thing that I liked about external secrets operator. Right? The things that I didn't like much, yeah, there is still a secret. So if you have read access to the cluster, you can go read it and know the password. Yeah. And second thing is, because external secret operator brings this new aspect of rotation, right? So secret value gets changed in the cloud. It will get changed in the secret object inside the cluster, but your application will not know about it. Your application has already mounted the old copy, right? So your application must have ways to detect that the cluster, the secret was changed, and you have to make the rotation. But I mean, things like Stakeator Reloader can help us here. Yeah. So let's quickly see a demo about it. So you can see that we have. I hope this is readable, right? By the way, VS Code. Yeah. Okay. So again, yeah, here the demo is, we are going to look at a secret called secret operator demo secret, but this secret does not exist right now, right? This will get created by what is known as a CR called external secret, which is going to go, I have told him that, please, boss, you go to this particular secret in AWS and grab the secret, and once you have the secret, you please create this particular secret for me in the Kubernetes cluster, right? And that's what will happen. Right now, if you see, there is no such secret called external something something. Yeah, it's not it. And so let us now go to the Argo CD, and you can see that I cannot make it bigger. Yeah, you can see that there is this external secret example that I was showing you, and secret store. Secret store is, by the way, how external secret operator knows which cloud to go and read from, etc. Yeah. So I will make a sync of it. Make it 0 back again. And did I say sync? No? Okay, it is, yeah, it's slightly slow. Yeah, so this is a secret that is being read from my AWS Secrets Manager. This is the CDS 2023 Secrets Operator secret. You can see the secret value here. Yeah, this is the secret read by external secret. All right, so yeah, so we have multiple different strategies, but I still don't like the fact that they all use, they all create actual secret which is still readable in the cluster, right? So another solution that has now come on the horizon is called external secrets driver. Oh, sorry, Secret-CSI driver. By the name of it, it is a CSI driver. Anybody know CSI? Cloud Storage Interface. Yeah. So it's usually used for provisioning volumes, right, at different cloud providers. So Secret-CSI driver builds on top of it. So it gives its own implementation to create volumes out of secrets. Secrets which are not in the Kubernetes cluster, but secrets which are outside somewhere at the cloud provider. So in this case, secrets are stored at the cloud provider, and you need to have the Secret-CSI driver running in your cluster in order for it to connect to very appropriate cloud provider, grab the secret, and make it available as volume, not as a secret, as volume. So it will directly make it available as a volume to the pod. So now, good parts, no secret objects are created in cluster at all. They were neither they are in Git for anybody to read. So the security improves, the attack vector goes down, right? And again, just like external secrets operator, here also the secret, if it is rotated at the cloud, it will also be reflected in the application. While by the read access that you used to have for Kubernetes cluster, you could have read the secret. If you still have access to do exec on the pod, which is slightly lesser case, yeah, you can still obviously log into the pod and go to the mounted directory and see the secret. So it's not 100% foolproof solution yet, but slightly better than external secrets operator way, right? And just like external secrets operator, problem is that if the secret gets rotated, new value comes, your application must deal with it. It should be having some kind of a watch on the secret file so that it can refresh it. So how does Secret-CSI driver works? So we install Secret-CSI driver, which is a CSI driver implementation, which basically talks to kubelet to create volumes. So this is generic. This is not cloud specific. This just gives you the basic framework or guardrails to create those volumes. Yeah? But how to get the secrets? Each cloud provider has different platform on their side to store the secrets, right? And APIs also. So then what happens is they give their own cloud-specific Secret-CSI provider, which will be able to talk to Secret-CSI driver. So AWS has their own GCP, Azure, and Vault. I think there are 4 of them at the moment available. In the demo, we will see AWS and Azure. So these providers, they will talk to the appropriate respective clouds, and get the secret downloaded, refresh, and all that. How will they work? They need some configuration information as to which cloud, what is the name of the secret, what is the content in that particular secret, and such kind of things, right? So for this, we have a CRD called Secret Provider Class. So you create an instance of it, and you provide all that information so that the provider guy can now know which cloud to go, what is my secret name, what content out of it I need to pull in, right? Yeah, so that's what it will do. So it will go to the cloud, read the content and provided it to the application pod as volume, right? So we will quickly have a demo of that as well. Okay, so the first parts, right? The CSI driver and the provider, they have been installed already in my cluster via Helm. So they're pretty standard, just hardly any customization, just deployed in my cluster, right? The CR, on the other hand, I must provide my own configuration. So we will see that configuration now. And of course, application pod, structurally, you know, it's a pod, service, and ingress. So that remains same. So I'm looking at Secret-CSI demo apps. So I have two of them. They are largely same, so probably I'll spend time only in one. Yeah, so this is my AWS app. You can see that it also has a, okay, so how you configure is you provide volume. Because it's a CSI implementation, you need to mount the secret as a volume and not as a secret, right? So you're going to mount it as a volume, and you are going to say, how does it know that it's a special volume? So because you give this CSI spec there, and you also tell him that which secret provider will be able to give you the required secret for your pod. Yeah, and so this secret provider class, AWS secret provider config, is here. You can see secret provider class, right? And what it is telling is that, boss, my provider to provide the secret for you is AWS. So go to AWS. In AWS, look for secret manager. And in the secret manager, look for a secret called my secret. And whatever is the content there, that's the content. Please mount it in that pod. That's basically what secret provider class is doing. And I also need this service account because AWS makes it slightly difficult for me to go and automatically talk to them. So there is something called as IRSA or IAM for service accounts. So I have some specialized role definitions created in AWS so that my cluster can talk to AWS and get this service secret manager data out, okay? It's unfortunate, but it is there. That's what it is, right? So let's go and have a look at our application. Okay, all others are done, and now I do sync for Secret-CSI app. And so if I go to the AWS secrets and my secret, you have something like username as CDS user, password as CDS demo. I mean, in reality, it's a JSON like this. And I'm going to edit it, but I will not save it. I'll make it to Vijay, but I will not save it for now. Let me first show you the old version of it. Yeah. Sorry. All right, so it went, it picked up the data and mounted it as a volume, which my application read and showed it to you, right? And also the secrets are refreshable. Currently, I have kept a very high refresh interval at, I think, 15 seconds or so. But of course, if you do that, then there is going to be a lot of AWS calls, and eventually it might bump up your AWS bill slightly. All right, so let's hope for the best, and let's see. Okay, it works. So far, demo gods are with me. So the secret gets refreshed. Similar demo for Azure also is there. So you can see that this is the secret that I had in Azure. Don't ask me why Azure. Actually, I'll tell you why Azure. Because Azure allowed me, their implementation is the simplest to get to run without this IRSA nonsense with AWS. Sorry. Yeah. my super secret on Azure. Yeah, that's what it is. And you can also update. I mean, again, whether updates are supported or not, all of this is provider specific. So not every provider supports all the features of the Secret-CSI driver. But this particular feature is supported by all 4 cloud providers. Well, I think that was the demo part. Only to quickly talk about, then, is it all great? And why should we stop using secrets altogether or not so? Right? So, yeah, it's not 100% beautiful solution. Most importantly, because it stops using a already well set, guided system, which is using secrets. So all the Helm charts that you are going to use from third parties, they use secrets. And now there are no secrets. So every Helm chart is going to break if you try to use Secret-CSI driver. But I'm hopeful, like how maybe you guys might know Service Monitor from Prometheus operator. Again, it was a very non-standard thing, but it became so popular that almost all the standard Helm charts these days provide you a way to create service monitor objects. So hopefully, who knows, another 1 year down the line, it will create these secrets also, right? And yeah, but is it good for your own Helm charts, your own applications? Yes, certainly. You can go ahead and change your Helm charts so that they all work with Secret-CSI driver for sure. Another thing that, as I was saying, the IRSA thing for AWS, right? So such kind of things exist for all the clouds. So right now, having cross-cloud provider compatibility is hard. I mean, right now my cluster is on AWS and I'm still able to use Azure, but that also means that I had to create a secret, ironically, to have a Azure client ID and client secret saved in my cluster. Then only it will work. If you want to not have that, then you must use AKS and then use Azure as your provider. So the cross-cloud provider compatibility is not the most easiest to achieve right now because of not limitation, but security measures taken by every cloud provider. All right, that's it. Thank you so much for listening.
Thank you so much. We have a little bit of time for a question, so let's do that. But also, I'm curious, everyone who heard Secret-CSI driver, who was thinking of CSI Miami and Horatio putting on his sunglasses in the coolest way possible? Thank you. Thank you. I wasn't the only one. Thank you. Excellent. All right, for technical questions. What was the name of the Git management tool that you used to commit the changes?
Sorry?
What was the name of the Git management tool that you used?
Okay, yeah. I'm very fan of this tool called Lazy Git.
Lazy Git, okay.
L-A-Z-Y, yeah. Beautiful tool.
Excellent. All right, let's see, for another one. Is the Secret-CSI driver already production ready?
Sorry, which one is it?
I'm highlighting them.
Okay, is Secret... Yes, I mean, I'm sure, I would say so, definitely, because if you look at all the 4 cloud-based secret provider companies, they all are supporting all the features that are there in the charter right now. So yes, it's pretty much production ready, yes.
Awesome. I'm gonna pick one more, I think, because then people want to break and maybe they go to the sponsor showcase. Nope. Let's do this one. What would be the best solution for a self-hosted Kubernetes setup? In your opinion, you can...
Yeah, okay. I mean, what you actually saw was a self-hosted per se. I mean, yes, it was running in AWS, but it was not a EKS cluster. It was a COPS cluster, meaning I had to do all the mumbo-jumbo, as I was saying about the secret service account that I had to create in order for my cluster to talk to the Secret-CSI driver. So it is possible, but it is not the most easiest thing to do. But yeah, if you look at the Git repository, you will already have some examples of it, how to achieve it.
Excellent. And then Vijay, I hope that people can just find you in the break if they have any more questions, because we do have a break coming up.
Yeah, for the next 5-10 minutes here or at the Kubernetes booth, you can always find me. Thank you.
Perfect.
Thank you for your patience.